yeah, in this video we are going to be using the quadratic formula to solve one heck of an awesome, yet actually pretty simple word problem. Let's check it out. It says the path of a soccer ball, it's been kicked, is modeled by the equation y equals negative 0.04x squared plus 2.9x plus 0.5, where x is the horizontal distance in meters from the starting point, and y is the height of the ball in meters off the ground. Okay, let's draw this out. So you got a soccer ball that's been kicked, right? And I'm going to just draw the first quadrant here because it's starting out, like if I kick the soccer ball, I'm at position x equals 0. And then the ball flies up and then goes down and hits the ground, right? So there's another 0 somewhere over here that doesn't matter. We only care about the 0 over here because what we're going to be asked for, and we'll see, is how far horizontally from its starting point will the ball land? We care about this 0. We care about where the ball hits the x-axis, the ground, a height of 0. All right, so what we're basically solving for is when is the height of the ball 0? So I'm going to set 0 equal to y because y is the, as it says, height. And that's going to give us the x value when we solve it out, which is the distance that we are from the y-axis, right? That horizontal distance. So negative 0.04x squared plus 2.9x plus 0.5. And now we're going to solve it out. All right, let's check this out, shall we? So all we have to do now is notice that I don't want to factor it, and neither should you. So we use the quadratic formula and then a calculator for sure, which I'm going to use in a second. So x is equal to the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And we'll utilize a calculator to make this a quick problem. Now, I want to remind you again, it was as simple as saying we want to know when this ball lands, which is when is the height 0, which is setting the equation equal to 0. That was it for the word problem. Once we determined that that's what we wanted, then we knew we were good. So now we're just going to use the quadratic formula. So the opposite of b is negative 2.9. Here's b right here, here's a right there, and here's c. Plus or minus the square root of b squared, which is going to be 2.9 squared, minus 4 times a times c. A is negative 0.04, so that's negative 0.04. That's kind of tiny, but there's a negative 0.04 in there, times c, which is 0.5. All over 2 times a, which is 2 times negative 0.04. Okay, so now how do you do all that in your calculator? Well, what I do is I literally plug all of the upper part in, and, well, actually I don't plug all the upper part in, I just plug the square root part, and let's find that as a decimal. So I get plus or minus, and I'll do everything in the square root. So I've got my calculator, here we go, we're going to do 2.9 squared, minus, and then I'm going to do 4 times negative 0.04, just making sure you're plugging it in correctly, times 0.5. And I double check it. Yep, I got everything in there. And that gives me 8.49. So that gives me the square root of 8.49, sweet, all over 2 times negative 0.04, which is negative 0.08. Okay, so now this gives us 2 answers. It gives us negative 2.9 plus the square root of 8.49, all over negative 0.08. It also gives us, and I don't want to come off camera here, or the plus or minus part, negative 2.9 minus the square root of 8.49, all over negative 0.08. Okay, so now here's the thing. We should do both of these and see which one gives us the sensible answer. So now I'm just going to plug the rest of my calculator. So I do negative 2.9 plus the square root of, now I'm going to use that exact 8.49 because that's what I got before. I get an answer. It's pretty tiny, 0.013 and change. And I divide that by negative 0.08. So that gives me negative 0.17. And that's not the right answer because we kicked the ball forwards. That's that 0 that happened over here in the parabola. So that is not our answer. So we'll go to this one. Negative 2.9 minus the square root of 8.49. That gives me negative 5.8 and change, divided by negative 0.08. Ah, it's more like it. Ooh, that's one heck of a kick. That's equal to 72, about 72.67 meters. That's pretty far. Okay, so the whole point of this, folks, is once you figure out that this is just a quadratic equation problem and that you want to know when the height is 0. You want to know when the ball lands on the ground? It's go time for the quadratic formula. Don't be intimidated by the word problem. Dive into it, translate it into something simple, and then use the tools that get you to your answer. Awesome stuff.